Hello, my dear students. Let me welcome you all to this special online session on quantitative aptitude. Today, we are going to discuss about progressions. And in this lecture, I am going to present in front of you 12 standard questions from this topic. We are going to discuss about arithmetic progression and geometric progression. Before you are going to attempt the questions, I'm going to share with you a few instructions. Please be ready with some rough sheets of paper and a pen. Please use headphones while you are watching this lecture. You may pause the video whenever it is required. Take your time to read and understand the question. Write down your doubts and queries and share the same with me during our regular classroom sessions. Important, please don't strain your eyes too much. Take necessary precautions and give proper care for your eyes. It is strongly recommended to take a short break after every 20 minutes of this lecture, and you may take a short refreshing walk during this time and then join back for the lecture. So, my dear students, let's begin our discussion. Presenting in front of you the first question. Please read this question carefully. All right. In this question, it is given that in an arithmetic progression, this AN, it stands for the nth term. So, you are also informed that the 7th term and the 9th term, if you're going to add them, that is equal to the 3rd term plus the 4th term plus the 10th term. Now, in the question, you are asked to find what is the first term of this arithmetic progression. Now, what is the 7th term of the arithmetic progression? That is A7. We know that nth term of an arithmetic progression, it is given by the expression A plus n minus 1 into D, where A corresponds to the first term, n, it corresponds to the number of term that is indicated, and D, it corresponds to the common difference. So A7, that is the 7th term. We know 7th term, it is equal to A plus 6D. We have the 9th term, A9, that is equal to A plus 8D. Now, the sum of the 7th term and the 9th term, that is A7 plus A9, that is equal to 2A plus 60 plus 80, that is equal to 14D. Now we are ready with the left-hand side of this given equation. Okay. Now let us focus on the right-hand side. A3, that is the 3rd term. It is A plus 2D. A4, that is the 4th term. That is equal to A plus 3D. And A10, that is the 10th term. That is equal to A plus 9D. Okay. Now, what is the sum of these three terms, that is A3, A4 and A10? That is equal to 3A plus 9 plus 3, 12, 12 plus 2, that is equal to 14. So, the sum of these three terms, it is equal to 3A plus 14D. Now, in the question, it is given that the sum of A7 and A9, that is the 7th term and the 9th term, that is equal to the sum of the 3rd term, the 4th term and the 10th term. So you can equate these two now. And from this, we can see that 2a plus 14d, that is equal to 3a plus 14d. We can see 14d, it is present on the left-hand side and right-hand side of the equation. So we can cancel the same. And this gives us the result 2a, it is equal to 3a. And from this, we can conclude that a, it is equal to 0. All right. Now, for this first question, we have thus answered. You are asked to find what is the first term of this arithmetic progression, and we have identified that the first term of this progression, it is equal to 0. I assume you are clear with the explanation for this question. Now, let us get into the next question. Please read this question carefully. In this question, it is given a group of 630 children. They are arranged in rows for a group photograph session. It is given each row contains 3 fewer children than the row in front of it. The question is, what number of rows is not possible? So, we can see that the total number of children we are considering in this question, that is equal to 630. So, this question, it has got to do with sum of n terms of an arithmetic progression that is given by the expression n by 2 into 2a plus n minus 1 into d. So recall, this is the standard formula to find the sum of n terms of an arithmetic progression. Now, this sum of n terms, it is given to be 630. You are dealing with some children here. So the number of children in the first row, it has to be an integer. So kindly note the reference what we have here is a. This has to be an integer. Okay. Now, in this question, it is given that each row contains 3 fewer children than the row in front of it. So this gives us the indication that the common difference in this case, that is equal to 3. All right. Now, with these inputs, I'm going to write the equation 630, that is equal to n by 2 into 2a plus n minus 1 into 3. Okay. Now, interestingly, I can see that I can write only one formula here or one equation here, and I can see that there are 2 variables here. The variables are n, that corresponds to number of rows, and a, that corresponds to the number of children in the first row. Okay. But for solving and getting unique value associated with this a and this n, right now the given information is not sufficient like that I can consider. But in the question, it is asked what number of rows is not possible, and we are provided with some options here. We can see whether the number of rows 3 is it possible, 4 is it possible, 5 is it possible, 6 is it possible, 7 is it possible. That's the question. And if you are able to detect that a particular number of rows is not possible, then that will be the answer for our question. All right. Now, what is the way out? How to solve this question? The best method is you can go for option reverse substitution. You check whether the number of rows that is equal to 3, it is possible. you substitute n is equal to 3 into this main equation. Okay. Now, the condition is, if you are getting the number of children in the first row, A, to be an integer, then we can consider 3 is possible. Let's try this. 630, I'm considering the number of rows to be 3, whether it is possible or not. I'm checking it. Okay. So 630, that is equal to n. Instead of n, I'm going to put 3. So 3 by 2 into 2a plus 3 minus 1, 2. Okay, so this is n minus 1. Instead of that, 3 minus 1, 2. 2 into 3, that is equal to 6. So I have an expression like this. And from this, I can see that 2a plus 6, that is equal to 630 into 2 by 3. You don't need to calculate the value. Okay. Because you can see that 630 into 2 by 3, this has to be an even number. Okay. Now, from this, you are subtracting 6. So I can thus conclude that 2a, I am getting this as an even number. From this, I can see that a will definitely be an integer. I don't need to know what is that value for a. I just want to make sure that a is an integer. So when I put the number of rows equal to 3 into this main equation, yes, I am getting that a is an integer, which means the number of rows equal to 3, it is possible. So like that, you need to check which is that number of rows which is not possible. So here, I can see that if n equal to 6, let's see what's going to happen. When n is equal to 6, we have 630, that is equal to 6 by 2 into 2a plus 6 minus 1, 5. 5 into 3, that is equal to 15. Now, from this, I will get 2a plus 15. That is equal to 630 divided by 3. Because you know 6 by 2, that is equal to 3. So upon simplifying this, I will get it as 2a plus 15, that is equal to 630 divided by 3. And this gives me 2a plus 15, that is equal to 630 by 3. We know 630 by 3, it is equal to 210. And this gives me 2a. It is equal to 210 minus 15. No need to calculate the value. You know 210 minus 15, which is an even number minus an odd number. So you can see this is resulting in an odd number. And from this, when I calculate the value for a, I can see that this a, it is not an integer. Okay, when I calculate 2a, which is equal to odd, from that when I calculate the value for a, I can see that this a, the number of children in the first row, it is not an integer. It is not possible. Okay, because the number of children, the number of students, there are number of children under consideration, it should always be an integer. And we can see that when n is equal to 6, that condition is getting violated. All right. So from this, I can conclude that what number of rows is not possible? 6, option D, that will be the final answer for this question. All right. So I assume you are clear with the explanation for this question. Let's get into the third question now. Okay, read this question carefully. It's a little lengthy question. All right. In this question, we can see a child was asked to add the first few natural numbers, that is 1 plus 2 plus 3 plus etc. First few natural numbers so long as his patience permitted. When the child stopped adding the first few natural numbers, he gave the sum as 575. When the teacher declared the result is wrong, the child discovered that he had missed one number in the sequence during addition. Now the question is, which was the number that he missed? So in this question, we are again considering the sum of first n natural numbers. Sum of first n natural numbers is given by the expression n into n plus 1 divided by 2. Now, we need to do this question, attempt this question by trial and error. Okay. So here we can see that when n, it is equal to the number 34. Okay, we can see that the sum of first 34 natural numbers, S34, if I'm going to calculate, it will be somewhat lying close to this 575 and within the range. Okay, suppose I'm taking S34, sum of the first 34 natural numbers, that is equal to 34 into 35 divided by 2. I can see that this sum, 34 into 35 divided by 2, the total, it comes to 595. So I can see that by a little bit of trial and error, had the child added all these numbers correctly, he would have got the total as 595. But he got the total here as 575 because he had missed one number in the sequence. Now it is evident that he missed the number 595 minus 575, that is equal to 20. And this number 20 is lying within the range, the first 34 natural numbers. So evidently, we can see that this child, he missed the number 20. So for this question, the answer, it is 20. Now, just for your information, I will show you why not it is some other number. If I'm going to consider the number of terms considered, say 35. Suppose I'm going to consider n, it is equal to 35. Then I have sum of first 35 natural numbers, that is equal to 35 into 36 divided by 2. And in this case, you can see the sum of first 35 natural numbers, 35 into 36 by 2, it will come to 630. Okay. Now, this would have been the sum that the child should have ideally got. But in the question it is given, the total that the child got, it was 575. Which means if I subtract 575 from 630, I get the result here as 55, which means the child should have missed the number 55. That is why he is getting the total as 575. He missed 55. So had he included that correctly, the total should have been 630. But here comes the conflict. He is adding only the first 35 natural numbers, and this number 55, it is lying outside the range of numbers under consideration. So we can see that this number of natural numbers that is under consideration, it cannot be 35. And we can thus conclude that it can only be 34. So when the child added the first 34 natural numbers, he accidentally missed the number 20. His total, it should have been 595, but since he missed 20, he got the total as 575, and that is what it is given in the question. Okay, so The number that he missed, it is evidently equal to 20. And this brings conclusion to our third question. All right. Now, let us attempt the fourth question. In this question, it is given if the sum of the first 5 terms of an arithmetic progression, that is S5, it is equal to the sum of first 10 terms. Okay. In the question now it is asked which term of the arithmetic progression must necessarily be 0. Now, what is the sum of first 5 terms of an arithmetic progression? S5, you know, that is equal to 5 by 2 into 2a plus 5 minus 1, that is 4 into d. I am using the expression to find the sum of first n terms of an arithmetic progression. So 5 by 2 into 2a plus 5 minus 1, 4 into d. Now, what about S10? We have it as 10 by 2 into 2a plus 10 minus 1, 9 into d. Okay. So, in the question, it is given that this S5 and this S10, they are equal, which means I'm now going to equate these two together. So I have the result here as 5 by 2 into 2a plus 4d, that is equal to 10 by 2 into 2a plus 9d. All right. Now, I can cancel 2, that is there here. 5 goes here 2 times. And thus, I have the result here as 2a plus 4d, that is equal to 4a plus 18d. I'm bringing this 2 inside the bracket. So that corresponds to 4a plus 18d. All right. Now, I'm going to take this 2a onto the right-hand side, 4d also onto the right-hand side. So I have 2a plus 14d, that is equal to 0. I can pull out the common factor 2 here. So 2 into a plus 7d, that is equal to 0. That's what I can see I'm getting here. So from this, I can conclude that here 2 cannot be 0. Product of 2 terms, if they are equal to 0, means one of them must be 0. So I can thus conclude that a plus 7d, that is equal to 0. Now, what is a plus 7d? A plus 7d is nothing but the 8th term of the progression. So from this, I can conclude that the question it is asked, which term of the arithmetic progression must necessarily be 0? Thus, I can conclude that here, the 8th term, T8, it must be 0. So 8th term, that is the answer for this question. All right. So this brings conclusion to our fourth question. Let us now get into the fifth question. Please read this question carefully. Okay. So in this question, it is given a total of 8,436 steel balls, each with radius 1 centimeter. They are stacked in a pile with 1 ball on the top, 3 on the second layer, 6 on the third layer, 10 in the fourth layer, and so on. The question is, what is the number of horizontal layers in this pile? So you can see that there is 1 ball on the top, 3 in the second layer, 6 in the third layer, 10 in the fourth layer, and this continues. Okay. Now, if you're going to add all these, that is this 1 plus 3 plus 6 plus 10 plus etc. up to the nth layer under consideration, you're going to add everything. This total, it will come to 8,436 because you are considering a total of 8,436 steel balls in this particular question. Now, how to proceed further? You can observe that here the numbers are 1, 3, 6, 10, etc. Now, how to connect this? How to find what is the logic here? I can actually see that 1 plus 2, that is equal to this 3 here. Okay. Now, this 3 plus 3, that is equal to the 6 here. The 6 plus 4, that is equal to 10. The 10 what you see there. So the next number, if you're going to consider, it will be 10 plus 5, it will be 50, and this pattern continues. Okay. Now, again, if you look at these numbers 1, 3, 6, 10, etc. closely, another interesting observation you can have. Let us consider the first n natural numbers. Okay, something like 1, 2, 3, 4, 5, 6, etc. We are considering some n natural numbers. This 1 that you see here is nothing but sum of first one natural number. Okay. This 3 that you see here, this is nothing but sum of first two natural numbers. You can see 1 plus 2, that is equal to the 3 what you see here. Look at this 6. The 6 that you see here is nothing but the sum of first three natural numbers. 1 plus 2 plus 3. 3 plus 2, 6. 3 plus 2, 5. 5 plus 1, 6. You can see it is 6 here. Okay. Now, what about this 10? This 10, what you see here, is nothing but sum of first four natural numbers. 4, 5, 6, 7, 8, 9, 10. Got it? So you got the idea? What you see here is nothing but sum of first n natural numbers. Suppose you are considering the nth layer, then you can see that in that nth layer, the number of balls that corresponds to what? That corresponds to sum of first n natural numbers. Okay. So, as indicated, you are considering the fourth layer means the number of balls in that fourth layer is nothing but sum of the first four natural numbers. 4, 5, 6, 7, 8, 9, 10. That's what you see here, right? So, nth layer, if you are going to consider the number of balls in that, it will be nothing but sum of first n natural numbers. That is the logic here. Now, what is the expression to find the sum of first n natural numbers? We already know that is n into n plus 1 divided by 2. Now, how are you going to connect this to 8,436? Very simple. Summation from the first layer to the nth layer you are considering. N into n plus 1 by 2. This corresponds to 8,436. Thus, I can see that here summation from the first layer to the nth layer, n into n plus 1. This value corresponds to 8,436 into 2. And that is equal to 16,872. We will get the result in this manner. Now, I'm going to do the summation here after expanding this. So I can see that this is nothing but summation 1 to n, n square plus summation 1 to n, n that is equal to 16,872. We need to find the value for n. Okay, because you are asked to find how many or what is the number of layers in this pile. So you are asked to find the value for this n. Okay. So let me now expand this. What is the sum of square of first n natural numbers? That is n into n plus 1 into 2n plus 1 upon 6 plus sum of first n natural numbers, that is n into n plus 1 divided by 2. That is equal to this 16,872. Okay, you may feel that we are getting a very big equation here and we need to sit and solve this and then get the value for n. Okay, nothing to worry. We can very well do this question by doing reverse substitution because you are asked to find the number of horizontal layers, right? So you have that n value here given in this set of options. So it is just a matter of doing reverse substitution, get the value for n, put it over here and see which is that value for n that satisfy this given condition. That's all you need to do. Okay. So you can see that here by reverse substitution, if you put n that is equal to 36, you can see this condition, it will be satisfied. Okay, you can see when n it is equal to 36, you can see that it comes as follows. 36 into 37 into 2 into 36, 72 plus 1, 73 divided by 6 plus, you can see n equal to 36. So 36 into 37 divided by 2. You just need to put these values here. And then when you do this total, you can see that this total, it will come to 16,872. Okay, so by reverse substitution, it is very easy for you to locate the value for n, that is the number of rows involved. And we can see that that value, it comes to be equal to 36. Okay, so for this question, the fifth question, the number of horizontal layers in the pile, we can see that that value, it will come to 36. Option C, that is the answer for this question. All right. Now, let us get into the next question. In this question, it's given Tn plus 1. That is equal to 2Tn plus 3. It is given that T1, it is equal to 2. You are asked to find what is the value for T5. Okay, it's a very simple question. You can see that if you put n equal to 1, then you will get T1 plus 1, that is T2, that is equal to 2T1 plus 3. And that is nothing but 2 into, instead of T1, you can put 2. 2 2s are 4. 4 plus 3, that is equal to 7. So basically what you are doing here is, if you want to find the second term, what you're doing is 2 times the first term, you are finding it, and then you are adding 3 to this. So it is basically 2 into 3, 6, and plus 3, sorry, 2 into 2, 4. You know that T1, it is equal to 2. So you are multiplying that first term with 2. So 2 into 2, 4. 4 plus 3, that is equal to 7. That is what you are getting here. Okay, so using this logic, I can now very well say that T3, when I put n equal to 2, I will get T3, that is equal to 2T2 plus 3. I know that T2, it is equal to 7. So 2 times the second term, 7 2s are 14, 14 plus 3, that is equal to 17. So basically, I can see that the pattern is in this manner. First term, it is 2. The next term, it is nothing but 2 2s are 4. 4 plus 3, that is equal to 7. The next term under consideration, I know that 7 into 2, 14. 14 plus 3, that is equal to 17. Now I can predict the next term, that is the fourth term. When I put n, it is equal to 3, I will be getting T4. Okay, so that is nothing but 2 times the third term plus 3. That's all you need to do. So, the next term will be 2 into 17, 34. 34 plus 3, that is equal to 37. Got it? So that is T4. You are asked to find T5. So what will be T5? You will get T5 when you put n, it is equal to 4. Okay, so you can see T5 is nothing but 2T4 plus 3. So we can see that this value will be 2 into 37. 37 into 2, that is equal to 74. 74 plus 3, that value, it comes to 77. Got it? So this is something called as recursion. Okay, so we can see that here, given T1 is equal to 2, using this condition, by proceeding in this manner, we can see that T5, it will be equal to 77. All you need to do is multiply the previous term with 2 and add 3 to it. Okay, so that is what we are basically doing in this question. As you can see here, for finding the next term, multiply the previous term with 2 and add 3 to it. That's it. Okay, so for this question, we can see that the fifth term, that is equal to 77. And that brings conclusion to our question here. Let's go to the next question. Okay, in this question, it's continuation of what we just saw. You are given T5 is 125. You are asked to find what is T1. So you are actually coming in the reverse logic here. So T5, that is equal to 125. Okay. Now, if you want to find the previous term, what will be the logic? From this 125, you have to subtract 3 and then divide the result with 2. That's all you need to do. I'll show you how it actually comes. So T4 will be basically T5 minus 3 divided by 2. Okay, because you know that T5, it is nothing but 2 times T4 plus 3. So from this, if I'm coming back, you know that 2T4, that corresponds to T5 minus 3. So T4, that corresponds to T5 minus 3 divided by 2. That's all I did here. Okay. So you can use this logic for answering our question, for finding the terms. Okay. So we can see T4, it is 125 minus 3, that is equal to 122 divided by 2, that is equal to 61. So thus you got T4. Now, what about T3? To find T3, it's very simple. 61 minus 3 divided by 2. Okay. So what is 61 minus 3? 61 minus 3, it is equal to 58. 58 by 2, that is equal to 29. You can see, you want to verify this, you can do 2 times 29 plus 3 gives you 61. 29 into 2, you know that it is equal to 58 plus 3, that is equal to 61. So like that it proceeds. Okay. Now, what about T2? To find T2, you need to do 29 minus 3 divided by 2. What is 29 minus 3? That is equal to 26. By 2, that is equal to 30. Okay. So that is T2. So twice of T2, 13 into 2, 26 plus 3. That gives you the third term as 29. Like that it proceeds. Okay. Now, what about T1? You are asked to find the value associated with T1. To find that, what you need to do is 13 minus 3 divided by 2. 13 minus 3, that is equal to 10. By 2, we get the value here as 5. So from this, I can conclude the first term here, that is equal to 5. Again, you can see throughout, it follows the pattern. 2 times the first term plus 3 gives you the second term. 5 2s are 10, 10 plus 3, you are getting it as 13. 2 into 13, that is equal to 26, plus 3, that is equal to 29. That is the next term, the third term. 2 into 29, okay, that is equal to 58, plus 3, that is equal to 61. That is the fourth term, and thus we are getting the fifth term as 125. Okay, but we are coming in the reverse logic in this case. And for this question, the first term we are getting here T1, that is equal to 5. I hope you followed this explanation clearly. The answer, it is equal to 5. Let's get going. Let's get into the next question. That is the eighth question. You are given 1 by 1 square plus 1 by 2 square plus 1 by 3 square plus 1 by 4 square plus etc. The total, it adds up to give you pi by 6. You are asked to find what is 1 plus 1 by 3 square plus 1 by 5 square plus 1 by 7 square plus etc. in that logic. Okay. So let's get going. We can see that on to the left hand side that is presented here. This is nothing but 1 by 1 square plus 1 by 2 square plus 1 by 3 square plus 1 by 4 square, etc. And that value, you know, it is equal to pi by 6. Now, if I'm going to exclude all the even number terms here, that is 1 by 2 square plus 1 by 4 square plus 1 by 6 square plus etc. If I'm going to exclude these even number terms here, I can see that I will be getting what it is presented over here. Is it clear? From this total, I am just taking out all those terms like 1 by 2 square, 1 by 4 square, 1 by 6 square, etc. The result is I will be getting what is presented, what we are asked to evaluate. Got my point? So this helps me to conclude that we already know the totality that we have, that is equal to pi by 6. Okay. So from pi by 6, I am now excluding this 1 by 2 square plus 1 by 4 square plus 1 by 6 square plus etc. Got it? Now it's very simple. Okay, you can see how the calculation changes. Pi by 6 minus, you know, 1 by 2 square, you can write it as 1 by 4. 1 by 4 square, write it as 1 by 16. 1 by 6 square, you write it as 1 by 36 plus etc. Now in the next step, what I'm going to do here is pi by 6 minus, I'm going to pull out 1 by 4, the common factor. So that is nothing but 1 plus 1 by 4 plus 1 by 9 plus like that it goes. And very interesting to see that this is nothing but pi by 6 minus 1 by 4 into 1 plus 1 by 2 square plus 1 by 3 square plus etc. It goes like that. Now, you know what is the value that I have written here. That is this 1 by 1 plus 1 by 2 square plus 1 by 3 square plus etc. You very well know what is that value because we have already seen that. Okay, because you know this value is nothing but pi by 6. 1 by 1 square plus 1 by 2 square plus 1 by 3 square. As you can see here, this is nothing but this value is equal to pi by 6. Okay, so taking that into consideration, I can thus see that the value of this expression can be written as pi by 6 minus 1 by 4 times pi by 6. Okay, I'm just substituting the value for this over here as pi by 6. Common factor, I can pull out pi by 6 in that value into 1 minus 1 by 4. So we can conclude that here the result, it is nothing but pi by 6 into 1 minus 1 by 4, you know, that is equal to 3 by 4. You can thus cancel this 3 and this 6 here like this, and I will get the value as pi upon 4 2s are 8. Okay, so you can see that for this question, we are finally getting the value as pi by 8. Looking at the answer choices here, I can see that option A it reads pi by 8, and that is the answer here. Okay, so make a note of this. These steps, pi by 8 is what we have to consider as our answer. All right. So let's get going. Let's go to the next question, question number 9. Okay, you're asked to determine the first term of the geometric progression. It's given the sum of whose first term and the third term, it is 40. The sum of the second term and the fourth term, it is 80. We are dealing with geometric progression here. Okay, so first term, if I consider it to be A, R being the common ratio, the third term, it is nothing but AR square. So A plus AR square, that is given to be 40. The sum of the first term and the third term, that is given to be 40. The sum of the second term and the fourth term. Second term, it is AR, and the fourth term, it is AR cube, that is equal to 80. This is what it is given in the question. So let me call this as equation 1, and let me call this as equation 2. So we have A plus AR square is 40, AR plus AR cube, that is equal to 80, as you can see. Now, from this second equation, if I pull out AR, I have AR into 1 plus R square, that is equal to 80. This is nothing but equation 2. And from the first equation, if I pull out A, I have A into 1 plus R square, that is equal to 40. This is the first equation. If I divide these two equations, as you can see that here, this 1 plus R square, this gets cancelled. A will get cancelled. 40, it goes in this 80 2 times, and we will get R, the common ratio value, that is equal to 2. In this question, we have thus identified that the common ratio value R, that is equal to 2. Substitute the value for R either in the first or in the second equation. It is convenient you substitute in the first equation. Thus, you can see that A plus A into R square, that is equal to 4, that is equal to 40. Thus, you have 4A plus A, 5A, that is equal to 40. That gives you A is equal to 40 upon 5, and that is equal to 8. Thus, for this question, we identified the first term, that is equal to 8, the common ratio value, that is equal to 2. You are asked to find this first term that we have identified as 8, and the common ratio here, I got the value as 2. Okay, so that is the way we can solve this question here. Okay, so we have arrived at the answer. So let's go to the next question, question number 10. It is given in an arithmetic progression, the 8th, 12th, and 17th terms are in geometric progression. So what is the 8th term of an arithmetic progression? That is A plus 7D. Okay. What about the 12th term? 12th term is A plus 11D. And what about the 17th term? A plus 16D. Okay. So we can see that these three terms, they are in geometric progression. Now, kindly note, if P, Q, and R, they are in geometric progression, the result is Q square, that is equal to P into R. Okay, so we will be using this result for solving our question. Kindly note P, Q, R. If they are in GP, that is geometric progression, we have Q square, that is equal to P into R. So here we can see A plus 7D, A plus 11D, and A plus 16D. They are in geometric progression, means A plus 11D. Okay, it's square. that is equal to a plus 7d into a plus 16d. That's what we have. Okay. Now, let us expand this expression. We have a square plus 121d square plus 22ad. I'm just expanding this. Okay, that is equal to a square plus 16ad plus 7ad. That is equal to 23ad plus 7 into 16 d square. You know what is 7 into 16? That is equal to 112. Okay, so we have 112 d square. Now, here I can cancel a square and I am going to rearrange the terms here. Okay, so I can see there is a 22 AD here and a 23 AD here. So I can thus see that AD, that is equal to 121 d square minus 112 d square, and that is nothing but 9 d square. So I can see that by arranging the terms, rearranging the terms, I have AD that is equal to 9d square. And I can cancel 1d here, and that's I get the result here as A is equal to 9d. Please make a note of this result. A, it is equal to 9d. Okay. Now, just now we identified A, it is equal to 9d. You are asked to find what is the ratio of the first term and the 10th term of this arithmetic progression. That is, you are asked to find what is this A divided by the 10th term is nothing but A plus 9d. Okay, so you are asked to find what is this A upon A plus 9d. Okay, we can see this is nothing but A divided by, I am retaining this A here as A as such, plus instead of 9d, since I know A is equal to 9d, instead of 9d, I'm going to put it as A. So I have this expression as A by A plus, instead of 9d, I'm putting it as A. So I have it as A divided by 2A, and this A will get cancelled off. I will get this result as 1 upon 2. So the ratio of the first term and the 10th term, I will get this result here as 1:2. Got it? So 1:2 will be the answer for this question. Let's now attempt the next question. Question number 11. For answering this question, you need to remember sum to infinity of a geometric progression is given by the expression A by 1 minus R, where mod R should be less than 1. This is the logic that you have to note. Okay. So sum to infinity is guided by this expression A by 1 minus R. Okay. Now, in this question, we are considering a square. Okay. So let me draw the square here, a relatively big square. Okay. So I can see that. Okay, 1 second. I can see that for this particular square, as indicated in the question, the side it is given to be. A square is drawn by joining the midpoints of the sides of a given square. A third square is joined inside the second one, and this process is continued. If the side of the first square is 8 centimeters, so you can see this square has got the side that is equal to 8 centimeters. So you can see that the area of this square that is equal to 8 into 8, 64 square centimeters. Okay. Now what are you doing? You are locating the midpoint of the sides and you are just joining them and you are forming another square as indicated. Okay. So you can see you are joined 2. Okay, I'm continuing it. Okay. And I'm forming another square here. Okay. So by applying Pythagoras theorem, I can see that this will be 4 units and this will be 4 units. And this side of the square, it will be 4 root 2. Okay, so you can see that the side of the square, what I have drawn inside, that is equal to 4 root 2. This side also, you can see this is 4 and this is 4. So this has to be 4 root 2. So can you tell me what will be the area of the square that I have drawn inside? That will be 4 root 2 into 4 root 2. That is 4 into 4, 16. 16 into 2, that is equal to 32. Got it? So you can see that the area has actually got halved in this case. From 64, it has become 32. So continuing in this pattern, as indicated in the question, continuing in this pattern, if I am going to draw the third square by joining the midpoints of the second square as shown, if I'm going to draw a third square like this, then looking at this pattern, I can see that the area of that third square, it will be half of 32 and that corresponds to 16. Okay, so this pattern, it continues. So I can see that this is basically, this is continuing up to infinity, okay, because they are telling you it is going on indefinitely. So you can see the series here, it is 64, 32, 16, the next square, it will be 8, then comes 4, and it goes up to infinity. So you can see that here, the sum to infinity, you are asked to find the sum of the areas of all these squares formed. So that will be nothing but a, that is 64, by 1 minus, in this case, the common ratio value, it is equal to 1 by 2. So you can see this is nothing but 64 by 1 minus 1 by 2. All right. So you can see that this total, when you are going to calculate it, you can see that this total value, 1 second, let me erase this. Yeah. So this total value, as you can see, it will be coming to be as 64 by 1 minus 1 by 2. And that is equal to 64 divided by 1 by 2. And that is equal to 128 centimeters square. So if you're going to add all these areas of the squares so formed together up to infinity, the total, it will come to 128 centimeters square. And that brings conclusion to this question number 11. And here we go, the final question, the 12th question here. Read the question carefully. Okay. We can see that here, a tennis ball is initially dropped from a height of 180 meters. So as you can see, from this height, 180 meters, the tennis ball, it is dropped. Okay, so I will draw it. So it's coming down. Now it's hitting the ground. Now it has hit the ground. After hitting the ground, you know, this ball, it rebounds by 3/5 of the height from which it had fallen. So from here, it goes up by 3 by 5 times 180. Okay, 3 by 5 times 180. Whatever it goes up, the same height it comes down. It hits the ground again. Now you can see that the next time it goes up, it will be 3/5 of the 3 by 5 of 180. Okay, because you know this is the height now. It's 3/5. That is what it will be going up. That is nothing but 3 by 5 of 180. It's 3/5. That's what it will be going up. And the same height it will be coming down. And this process continues. Okay. So the next height that it will be going up, it will be 3/5 of this 3/5 of 3/5 of 180. Like that, this pattern continues. And you can see that it continues up to infinity. Okay, so that is the point that you have to note. So if I'm going to write all these steps in a mathematical way, you can see that first the ball comes down by 180 meters. Then it hits the ground. It goes up and down, that is 2 times 3/5 of 180. Now, the next instance, 2 times, it will be traveling 3/5 of 3/5 of 180. And this process continues up to infinity. So I will retain this 180. The first 180, I'm going to retain it here. plus I'm going to pull out the common 2 into 3 by 5 into 180. I'm going to pull out this one common. So that is nothing but after that I have 1 plus, then I have taken already 2, 1 3 by 5 and 1 180. Okay, so I have 1 plus 3 by 5 plus I have 3 by 5 square plus I can see 3 by 5 cube. This pattern, it continues in this question. Now, I can see that here, this results in 180 plus 2 into 3 by 5 into 180 plus what you see here is nothing but sum to infinity of a GP with first term as 1 and the common ratio here as 3 by 5. So sum to infinity, it is a by 1 minus r. So that is nothing but this 180. This is into, okay, kindly note, this is multiplication. Okay, so you can see that 2 into 3 by 5 into 180 into, you can see it is 1 by 1 minus 3 by 5. Got it? What is 1 minus 3 by 5? That is equal to 2 by 5. Okay, this value in the denominator, it will be coming to 2 by 5. And when you are bringing this to the numerator, this value will come to 5 by 2. Okay, so we can see that this is nothing but 180 plus 2 into 3 by 5 into 180 plus 180 into 5 by 2, because this value, sum to infinity value, you will get it as 5 by 2. Okay, now I can cancel this 5 here. I can very well cancel this 2 also. Thus, what it remains is 180 plus 3 into 180. That is nothing but 4 into 180. And 4 into 180. That is nothing but 720. So, you can see that this ball, it continues to move 720 meters before it comes to rest. So, for this 12th question, the answer, it comes to 720 meters. All right. So, my dear students, with this question, we have reached the end of today's discussion. And in this series, I have presented in front of you 12 very typical questions from progressions. I assume that you have followed this lecture closely. You have followed this lecture clearly. Make a note of all the doubts that you encountered, all the queries that you have separately. Next time when we are meeting in our regular class, then I will definitely address all those questions and queries, and thus your doubts will be getting clarified. Okay. So with this note, let us conclude this session. Thank you very much for joining. Thank you once again. Best wishes.